Welcome back to part 5, where we provide an extended demonstration on a more complex database. Consider the following entity relation diagram of a video game database. Games are stored in a game table, which has a game ID, the name of the game, and a foreign key to the publisher. The publisher table has a primary key, publisher ID, and the name of the publisher. There is a one-to-many relationship between the publisher and the game table. Therefore, one publisher can publish multiple games. There is also a platform table, which has a primary key platform ID and the name of the platform. This is so that one game can appear on multiple platforms, and one platform can have multiple games on it. This is modeled through the availability join table, which has a primary key, auto-generated, and two foreign keys, one to the game table and one to the platform table. It also has an additional optional column called Publish Year. This is to model the fact that one game could be published on multiple platforms in different years. Let's do a series of exercises on this database now. First of all, let's write a query to list all the games in the database. There are a total of 20 records in the game table. Now let's list all the video games that start with a G. We use a like clause along with a wildcard. Now let's list all the publishers in the database. There are a total of 13 publishers. Let's list all the video games in the database along with all their publishers. To do this, we'll need a join statement. I started from the game table and then joined to the publisher table. I know that all the records are preserved because a game record cannot exist without a publisher record because it has a foreign key. Now let's list all the video games along with their publishers, but only the relevant fields. In other words, we'll get rid of all the primary keys and foreign key IDs. It works, but it's confusing, as we have two columns with the same name. This is a good opportunity to use some aliases. And now we can distinguish the two columns. Let's list all the publishers in the database along with all their games, even if they don't have any. To do this, we'll need to start at the publisher table. Here we're missing some records because we used a regular join. To preserve records in the publisher table, even if they don't have any game records, we need to provide a left join. And now we can see all the publishers that don't have any game records in the database, including Sony, Square Enix, Sega, Blizzard Entertainment, and Atari. Let's list all the publishers with a count of the number of games they have. Our first query didn't work because we didn't use a group by clause. Instead, we got the first publisher name, LucasArts, pulled out of the database, along with a count of all the game IDs after the join. Recall that we had 20 games in the game table. That's where this number is coming from. To get the answer that we want, we need to use a group by clause. And now we have the result. It's still not complete, however. Recall that we had 5 publishers with no game records. We again need to use a left join to capture all of those records. Let's write a query to list all the games on all the systems that they're available on. This will require us to go from the game table to the availability table to the platform table. In other words, we'll need to do 2 joins. Again, because we're using regular joins, we're not getting any game records that are not available on any system. We're also not getting any systems that don't have any game records. Let's modify that to now list all the games that are not available on any system. To do that, we could simply just change all of our joins to left joins to preserve the records. And now we see that there are 5 games that are not available on any system. However, we didn't need to go all the way to the platform table. If there were no availability records joining a game to a platform, then we know that they're not available on any system. We can omit the second join. And we get the same 5 records. To limit our results to only these 5 records, we can put in a where clause. Recall that we cannot do this with null values. We need to use the syntax is null. We can restrict the columns to simply the game information. Let's find the oldest game or games and the platforms that it's available on. Recall that the availability table has the published year in it. Let's find the oldest published game. The oldest game was published in 1985. To find which game this is, we will need to start at the game table and join to the availability table. We also want to include the platforms, so let's use the query from before. Super Mario Bros. Published in 1985 on the Nintendo Entertainment System. However, in this query, I've hard-coded 1985 because I made the query from before. If we want to make this query more general and work on any future records, then we need to use it as a subquery. In this instance, we only got one record that was published in 1985. If there were multiple games that were published in 1985, we would have gotten more results. Let's go ahead and flatten the entire data model by returning all data on all games. That is, we'll join all 4 tables together in one. This won't work because I've reused the alias p twice. We'll need to change at least one of them. Recall that I'm using a left join here. From the game to the publisher, that is safe because a game record cannot exist without a publisher record. However, I'm not capturing any publishers that may not have any game records associated with them. To do that, I would have had to start at the publisher table and do a left join onto the game table. Likewise, I'm not capturing any platforms that don't have any game records. I would have had to start at the platform table in order to capture those records. Let's insert a new game, Assassin's Creed, published by Ubisoft. Recall that special characters, like the single quote, must be escaped. Furthermore, though we don't have to provide a game ID because it's auto-generated, we do have to provide a publisher ID. I'm not sure what the publisher ID for Ubisoft is. Let's again select out all the publishers. The record does not exist. We'll need to insert it before we insert the game. Again, we don't have to provide the primary key as it is auto-generated by the database. The Ubisoft record now has publisher ID 14. I could hard-code that and execute this query. Instead of hard-coding 14, I could provide a subquery. The record has now successfully been inserted. Let's make our new game available on at least 2 different platforms. We'll make it available on PlayStation 3 and Game Boy. Since the platforms already exist, we'll simply need to insert records into the availability table. Once again, I've hard-coded these values. As an alternative, I could have used subqueries. Both queries were successful. Let's go ahead and observe the results from our previous query. Assassin's Creed is available on 2 systems, PlayStation 3 and Game Boy. Observe the record for Mega Man 3. According to our data, it's been published by Eidos, which is wrong. The publisher should be Capcom. Let's update this record so that the correct publisher is in our database. To do so, we don't need to update the publisher table. Instead, we need to update the game record, because it's the one with the bad publisher ID. Capcom is publisher 8. So we will update game and now our records show that Mega Man 3 is published by Capcom. Let's delete the publisher Eidos. We can see that the publisher ID of Eidos is 10. It didn't work. The reason it didn't work is because there are still game records that are referring to the publisher Eidos. In particular, Tomb Raider, which is available on 2 systems, PlayStation and PC, refer to the publisher Eidos. We would first have to remove these game records. Game ID 12. It still didn't work, because there were availability records that referred to this game. It was available on 2 systems, recall. So first we need to delete those records. Those 2 rows have now been deleted. And we can now delete the game. And now we can delete the publisher. Let's write a query to return all the games along with the number of platforms that they're available on. Again, this is a group by aggregate using the count function. But we need to join from the game table to the availability table and then possibly all the way to the platform table. To preserve game records that are not available on any system, we'll need to use a left join. Let's only select the game name along with a count of the number of systems that it's on. Some of the records look correct. For example, Assassin's Creed, we made it available on 2 systems. Others don't. Recall that we have at least 4 games that are not available on any system from a previous query. When we run this query, GTA, GTA 2, and GTA 3 seem to appear on 1 system, even though they're not available on any system. This is because we were counting all the records. It appeared once, even though its platform ID was null. Instead of counting records, we need to count platform IDs that are non-null. And now we get the desired result. Observe, however, that we didn't need to go all the way to the platform table to determine this. The platform ID is in the availability table as a foreign key. If we count it instead, we get the same results by only joining 2 tables. This database, as well as the solutions, are available on the website. You are encouraged to continue playing with it and writing your own queries.